Okay, so in number 1, we've got 904 divided by 5. When you have that second number being divided by a certain, whatever that value is, in this case it's 5, that's the number that's going to go on the outside. If you remember your long division, you have a symbol that looks just like that. And the number that goes inside your division box is 904. So the way that you would deal with this situation is you would work inward piece by piece. So you would try to figure out if 5 can fit into 9. So 5 can fit into 9 one whole time. So then you take that 1, then you multiply it to that outside number, 5. 1 times 5 gives you 5. And then we subtract. So 9 minus 5 gives us 4. Since 4 is smaller than 5, we know we have to bring down our next number. So that becomes 40. 5 goes into 40 how many times? Well, that would be 8. Since we brought the 0 down, the 8 goes right above the 0 in its placement. 8 times our outer number 5 now gives us 40 back. We're going to subtract those two numbers. 40 minus 40 gives us 0. 0 is smaller than 5, so we have to bring down our 4. So now we're looking at 4. How many times does 5 go into 4? 0 times, because 5 does not fit into 4. So 0 times 5 gives us 0. Subtract those numbers, we get 4 left over. So now we have no other numbers to pull down here, but we have a remainder. So there's two ways we can go about doing this. The first is we can actually add our decimal to this spot, if you remember from probably about 4th, 5th, 6th grade. And if we add a decimal, we can add another 0 to that value next to our decimal. We can bring down another 0, which is 40. If we put a decimal inside, we have to make sure that we put the decimal as well in our upside number, or our number on the top. So 5 now goes into 48 times. 8 times 5 gives us 40. Subtract those two numbers and we have 0. So our answer, 904 divided by 5, is going to give us 180.8. The other way that we could have done this, instead of pulling out the decimal and then adding the 0, is if we go back to where we first got that number. So we brought down the 4, and we had nothing else to pull down from except if we created a decimal and that 0. So if we go back to that point where we originally stopped that number, this is what we call our remainder. And I know that's a word that it's probably been a little while since you heard it, but that is a remainder. So before we added the decimal and the 8, we had 180 with a 4 left over as a remainder. So we could also write this as 180 with a remainder of 4 over the number that we were originally dividing by outside. These two mean the same thing. This one's in decimal form, this one's in fraction form. So they both mean the same thing. We're going to be going with this method as we move forward. We're going to be keeping things in decimal form as we start dividing polynomials, but that's just something to think about as we move on through lesson 6. In number 2, we have 985 divided by 23. 23 is our second number, so we're going to pull that outside. Our first number, the bigger one in this case, goes on the inside, and we're dividing. Number 2 is a little bit different than number 1 because we're dividing by a number that has 2 terms to it, 2 numbers, as opposed to 1. So when we start number 2, we're not going to start the same way we started number 1, because 5 went into 9. This was one number going into one number. In this case, 23 can't go into 9. So we have to go out one more and look at 23 going into 98. So how many times does 23 go into 98? And through figuring that out, that would be 4. So 4 times 23, 4 times 23 gives you 92. We're going to subtract these two numbers. 98 minus 92 gives you 6. I'm going to bring down my 5. I have a number that has two numbers on the outside, so I want to make sure that I'm comparing it to a number bigger than 23, a number that also has 2, so I have to make sure I bring down that 5. So 23 now goes into 65 2 whole times, and because we brought our 5 down, I want to make sure that my 2 is on top of the 5. 2 times 23 gives me 46, and if I subtract those two, I get 19. Now in this case, I could do the same thing I did in number 1, where I can add a decimal, add zeros, and bring down more numbers. Since 19 is smaller than 23, 23 cannot fit into 19, so I would have to create a decimal here with a couple zeros and bring those values down. Or I can just leave it this way, as 19 is what we call our remainder, and my answer would be 42 and 19 over 23 is my final answer. And we're going to leave it just like that. 42 is the whole number that we pulled out on top. 19 is our remainder, and our remainder always goes over our outside term that we were using to divide. Number 3 and number 4 are a little bit more simpler. We're just simplifying in numbers 3 and number 4, so this actually belongs to number 1. So I'm going to rewrite this down below. So I get 3x squared divided by x squared. What do I get here if I simplify? Well, the first thing I'm going to do is I'm going to write them as two separate columns of values. So this number that's invisibly in front of this x squared I know is to be 1. So I can actually put a 1 there if I needed to. And I'm going to separate my whole numbers, my constants out in front, times, and then I'm going to put my x squares in their own column. Well, 3 over 1 is simplified as small as it's going to get. X squared and x squared can cancel out to give me 1. So this whole answer gives me 3 if I were to simplify. Same thing in number 4. If I separate out my x terms and my constants, I get 8 over 2. It's my first column. My second column deals with my x's. So in this case, 8 over 2 reduces to 4. And remember, if I have same base, I take my exponents and I subtract them. So 7 minus 4 gives me x to the third power for number 4.